Today we're going to review some concepts about low-level C programming. But first, I wanted to talk a little bit about why we use C for embedded systems. And first off, C was designed for low-level programming tasks. It was actually a language that was designed to build operating systems. And with this in mind, before C, most commonly used was assembly language for developing operating systems and low-level programming and things like that. So the idea behind C is to make the workflow much more efficient, but still allow that low level of control, so we can know when we write a line of C code that it's going to translate to a specific sequence of assembly instructions. So we're not giving up any control, but we're making our program development much easier. Also, if we're looking at other most popular programming languages like C and Java, they rely on the operating system for memory management, right? Anytime we use new or delete, Java does garbage collection, stuff like that. That's all extra stuff that's happening on the operating system. So we're relying on the operating system to do that for us. The C language doesn't often rely on the operating system, right? It's kind of platform independent. That said, embedded systems don't have an operating system at all. So that kind of lines that out. It kind of removes that option completely. So the rest of this sequence, we're going to be talking about why, what is different between C and C++ or Java, looking at some of the language constructs and things that we can and can't do in C and C++, just refreshing your memory there. We're going to talk about memory and pointers, make sure you understand how memory is laid out and how the programming language interacts with that. Talk about how different data types interact in memory, and look at binary operators, refresh our memory on how binary operators work. These are the bitwise operators, how we can manipulate bits individually in these systems.